All right, guys. We now move on to dealing with circles. And it's basically like an anatomy class. We have a whole lot to talk about circles. This is a lot of information. So hopefully you write down most of what I say. It starts with a circle. Okay. A circle is a set of all points that are equidistant from the center. Okay. So that's what the definition of a circle is. So you got the definition for a circle. Hopefully you write it down on your paper. Okay, it's a set of all points that are the same distance from the center. So that means this, all of those are the same distance. Now, what do we call that? If this is the same distance, and this is the same distance, and this is the same distance, what do we call those segments? Correct. Hopefully you know they're called the radius. Okay. So the radius is from the center of the circle to a point on the circle. From the center to a point on. And all radii are the same, correct. All right. When you go all the way through the circle, I'll use a different color for this. When you go all the way through the circle, that is called a what? Correct. A diameter. Okay, and I'll explain to you that a diameter is a segment from one point of the circle to another point of the circle through the center of the circle. From one point to another point on the circle through the center of the circle. Okay, now remember, all that information is important. You can't make the definition any shorter. Just like a radius is from the circle to any point on the circle. Notice a radius is half of a diameter. Now these are things that you've known from before. Okay? You've had this information before. You've done this information before. Okay, here come the things that are a little bit different or new to you. Okay? The distance or pieces of the circle, a piece of the circle is called an arc, A-R-C, not A-R-K, not the thing that Noah built for all of his animals, okay? This one is A-R-C, an arc. Okay, and it's a piece of a circle. But you name things. So now we're going to talk about naming things. We name a circle for its center. Right? So let's just call this circle O. Okay, so it would be circle O. See, that works? It's a circle with a little dot in it, and it's called O. Okay, if we're going to name arcs, you have three types of arcs. You have a minor arc. Okay, and a minor arc uses two letters and is always less than 180 degrees. Okay, so in the picture above here, we have minor arc. We've got several of them. So I'm going to list some minor arcs. We have minor arc AB. We have minor arc BE. We have minor arc EC. We have minor arc CD. We have minor arc CA. Okay, so all of these are considered minor arcs. You have minor arc DB. Okay, so it's where I start and where I stop. Notice, I can switch directions and it's never the same direction. what happens is you know that you are going the shortest distance when it's only 2 letters because it has to be less than 180. In other words, I can't go D, B. That's not a minor arc, okay? This right here is a diameter. So it means if I start at D and I go past it, that's more than 180. Okay, that's called a major arc. Okay, a major arc is greater than 180, meaning I have to go past half the circle. So in a major arc, we use 3 letters. That tells us we're going past half the circle. So for example, I could say A, D, E. And because I use 3 letters, it's telling me it's bigger than 180 degrees. It's also telling me I have to go this way, from A to D to E. That is the same arc as a CE. Okay? A CE is the same arc. Why? Because it contains the same points. I only need 3 of them, and I could use any 3 as long as one's the beginning and one's the end. Okay. Let's do another major arc. D, C, B. Now these are all major arcs. D, E, A. Okay, so you have a bunch of major marks. But the idea is making sure that you have to go past halfway. Then you have semicircles. And semicircles are called semicircles. Okay? So there is no shortcut for writing it. Semicircle is exactly 180 degrees, correct? It's half the circle. So you'd say semicircle DE, semicircle DCE. It doesn't matter how many letters you use for that because you must use the word semicircle to establish it's a semicircle. All right, there's no shortcut. Semicircle. It is equal to 180 degrees. Okay? There is no shortcut. It is what it is. All right. All right, so now we move to finding these measures. Okay, we know that every circle is 360 degrees. And we're going to find pieces of that circle. So let's just pretend this piece here was 30 degrees. Okay, and we're going to pretend this piece over here was 40 degrees. So I would say to you, okay, so what is this arc measurement A to B? Well, 40 and 30 is 70. I know this is a semicircle, which is 180. If I know 70 of it, that means this piece must be 110. Okay? So you're using the measurements of 360, 180, and 90 to try and find the other pieces. What things will we have in this picture that we used from the past? Well, we'll have things like vertical angles. So if you know one side, you'll know the other. Okay? So these are all important pieces of 6-1. Why is this important? Because it helps us set up fractions and ratios and all sorts of fun stuff as we move on. But finding the pieces of the circle revolve around, do I know what the diameter is? Okay, so that means all this is 180. So all these pieces must add up to 180. Okay? It's kind of like a pie chart when you had all the percentages and they had to add up to what? 100%. Except now we're doing degrees and we know a circle always adds up to 360. Now, why does this become a little difficult? Because sometimes you might have to add pieces. So for example, let's say this one's x and this is 5x plus 2. I would go, oh, well, these two things must add up to 180. So I would do x plus 5x plus 2 equals 180. Find the answer, turn around, plug it back in, and find out what this section is and what this section is. All right, so these things still happen. Or add up all of the arcs to equal 360, correct? Or add up 2 of the arcs to equal 90. Okay. So all the stuff that we've been working on will still exist. So what I'd like you to do is try got it problem 1 from problem 1 and got it problem 2, and then check back here and we'll go over the answers. All right, it's good to see that you paused the video and you're back. We go to got it. Hopefully you know this was the circle. And it had this, and this, and this. So it had Q, P, S, A, and R. Okay, and hopefully you know all capital letters. It says, what are the minor arcs in A? Hopefully you know the minor arcs would be, in circle A, would be arc PQ. Remember, you got to use this. 2 letters, SP, SQ, SR, RQ, QP, which is the same as PQ. Let's see if I missed any. PQ, P, no, PS, SR. Okay, so those would be the minor arcs. And then it says, what are the major arcs? Actually, it says, what is the semicircle? So the semicircle would be semicircle RP. Okay, semicircle RP. Now, they can use 3 letters, RSP. It's the same, but you got to say semicircle. Now, if you're just going to use 3 letter, if you're just going to name 180, you've got to use semicircle so that you know that you're talking about a semicircle. Okay, in the book it doesn't always do that, but we want you to use the word semicircle. Then you can use 3 or 2 letters. And then your major arcs, okay, which would be SPQ, QPS, or excuse me, QRS, SQP, SPR, and last but not least, RSQ. All right, and the second got it. It asked for the measurements, and your circle went like this. And I'll do those measurements right on top of the actual picture that's there. They gave you 77 degrees. You know that they add up to 180, so this would be 103. They gave you 28 degrees. You know, this adds up to 180, or the whole thing adds up to 360, which would make this 152. All right, so then you have to go back and find the measurements that they're talking about. They talk about PR. PR is already on there, 77. They talk about RS. We did that. That's 103. They talked about MPQ. Now, you should know that's over 180 degrees. So you would go from P to R to Q. So you would start from here. You'd go P to R to Q, which means it's 180 plus another 28. Okay, all the way around. So that would be 208. And then last but not least is PQR, which goes this way, P to Q to R, and it's basically the entire circle except the 77. So you can do 360 minus 77, and you end up with 360 minus 77. You end up with 283. All right, good luck on the homework.